So that was a very good, particularly the last question around that allowed Rogerio to ask, around the mobile integration and mobile devices. The next two talks are the first one by Leon from Optron is going to be talking about the hardware that we now have available to us to be able to go out into the field, get accurate measurements, accurate, very accurate coordinates, and be able to be productive in the field. Immediately thereafter, Dean is going to be providing an example of how we've included a mobile technology on that hardware with Esri software to be able to go and do inspections in the field. So over to you, Leon.
Good afternoon, everyone. Can everyone hear me? I'm a bit tall, so if I need to use my outside voice to shout. Guys, thanks for having me. My name is Leon Reynders. I've been with Optron for the last 5 years, a bit over 5 years now. Started off as a sales consultant in the Western Cape region, and then in the last 2 years, I actually moved over with our Africa team, where we look after various countries into Africa. Just a quick intro. I'll just be covering basically. I think the theme is just going to be cost-effective GNSS data collection, and I'll also talk a little bit about drone data collection as well. If we don't have a lot of time for Q&A, you guys can always come chat to us afterwards as well at our stand. I'll be happy to ask any questions there, or if you want to see anything in action, you're welcome to speak to me afterwards. So just a little bit about Optron. We were established in 1986, and in 1987 we became an official Trimble dealer. We were actually the first Trimble dealer outside of the USA, which is quite a feather in our cap. And we represent a wide variety of brands, but Trimble being our main focus. So our vision is to be a world-class leading position-based technology company. And we've come quite far over the last, I'd say especially over the last 5 years, from just moving boxes to focusing not only on hardware, but software solutions and services that pair with our technology. So apart from Trimble being our main products that we supply, we also look after various, or partner with various other partners to, and again, this is just third-party products that we provide that work in conjunction with the Trimble products that we supply, to just really provide a full service for our clients. Moving straight into the GNSS data collection side, something I just want to focus on today is the Trimble Catalyst solution, more specifically the DA2 solution. But before we start with that, I thought we'd have a quick look at the conventional methods we used out there to, in the past, to collect spatial or accurate spatial data. It used to be that you had to get something like a GNSS system, which consisted of a base and a rover, or you'd have to get a total station. But with this technology, as good as it is, there is some disadvantages to this kind of technology. These products generally tend to be quite expensive, which require a large initial investment. In a lot of companies, they end up being underutilized with, pending the use and the application of this equipment. A lot of it requires multiple operators, and there's an extensive learning curve linked to actually getting going and learning how to use this product. The other thing as well is traveling with this equipment. It's quite heavy, and it takes up quite a bit of space. It's not easy to get on an airplane or get in your car and just go. So what is the Catalyst? So the Catalyst is a combination of hardware, which includes this little GNSS antenna. It's very small, very lightweight, and you pair it with something like a smartphone or a tablet or rugged field devices, which is what we recommend. And then we pair it with with software and subscription-based accuracy options to provide a full data capturing system in the field. So one of the emphasis is the lower cost of entry for this. It's a very small, very powerful solution, but I think one of the things I'd like to focus on is just the flexibility of this device and how it can be used in the field. And you'll see that word flexibility as I go through my presentation, because I really want to emphasize how it works. So there's various options how you can work your subscriptions. It's all dependent on the end user themselves. So you've got the option of looking at like a yearly subscription, monthly, which is 30 days. You can customize your plan. So in various industries, like when we work with governments, we understand that there's not budget every year available for equipment and subscriptions. So in those cases, we work with Trimble and we look at providing something like a 3 or to 5 year subscription option instead of just pairing 1 year and having guys go for 1 year and having to renew that year and year. There's also a 10-hour pack available where you can actually allocate an hour onto your, or 10 hours onto your account, and you use an hour as you please. Accuracy, this is also completely dependent on the end user. So if we look back at that GNSS system that I was talking about earlier, that would have been, you've got one option, and that is centimeter accuracy that you're going to work with. But with the Catalyst, you're not limited to just having centimeter accuracy that you're capturing in the field. You've got the option of going for from centimeter all the way up to sub-meter accuracy. Now, there's different costs linked to these subscriptions. Generally speaking, as the accuracy goes down, so does your cost, with your highest accuracy being the most expensive option for it. I think I can show a good example of where this kind of technology, it hasn't been available in the past to us, but if I look back 15 years ago when I was still surveying out in the field, the firm I worked for, pretty much 80% of the work we did was for Eskom, our power utility in South Africa. And a lot of that work we did was we required centimeter accuracy. So we needed to survey, design, and then as well as stake out the new power line structures. There we needed centimeter accuracy. But a lot of the other projects had a different scope to it. They had things called like pre-marketing, where we would actually go into rural villages, collecting data on the houses where there's no electricity. We would capture the house position. But there you needed you didn't need as much accuracy, but still I had to use that same equipment and I had to, in areas with difficult topography where I'd lose radio signal from my base, I had to set up a base every morning. A solution like this would have been absolutely ideal, where you can actually utilize the accuracy you need per job that you're doing. Now, along with that flexibility, you can also look at software options which would fit your needs as well. Again, not every end user has the same desired or project scopes that you might have. We compare a software subscription in accordance with your accuracy. So again, it can either be a 30-day or a 1 year or multiple years that we can actually look at customizing a plan for the end user. Again, we'd look at the application and then recommend a software from there. But you're also not limited to Trimble's software only. You can actually use pretty much any third-party software. We've seen quite a lot of it out there. Quite a lot of end users tend to choose their own software that they might have developed as well, that might just need a higher accuracy linked to the data that they're capturing. And then what do you do with the data afterwards? So with the Catalyst, you've got the flexibility of also exporting a variety of formats. You don't need to just bring that data into Trimble. You can export it directly in whatever format you need to bring it into a third-party software, whether that be something to do with Trimble Landfolio or Esri, something like that. So the engine powering the accuracy behind Trimble Catalyst is Trimble RTX. And That's what actually gives you your accuracy. That's the accuracy subscription I was talking about, where you can go from either 2 centimeter or to 1 meter accuracy. If you look on the screen here, we've got the world map here now. RTX pretty much covers everything all around the world, but there's different areas. If you can see the areas of blue, that is where your initialization time, in other words, from when you start your survey to where you get down to your required accuracy, whether that be 1 centimeter or meter, it takes, the blue areas take about 1 minute, and then the rest of the areas are covered in yellow. And in those yellow areas, it takes around 3 minutes to come down. We've recently tested this in South Africa, and it has not let us down with that time frame. So what do you really recommend as a solution? Again, this also depends on what your application is. If it's something like survey, we would recommend the DA2 antenna. So that's just the antenna like we have here. It's powered by a power bank, external power bank that you mount onto a 2-meter survey pole. We look at what you want to do. We recommend software. We recommend an accuracy that you require. We build your bundle to what you need. And again, the hardware is a once-off purchase, and then if you're free to use the Catalyst subscription as you want. If you've got a project that's 3 to 4 weeks, then you activate 30 days. You use it for that 30 days. After that, it switches off, and you don't use it for another 6 months or a year. If you've got another little project that you need to activate it for, at maybe a different accuracy level, you've got the freedom to do that. But the key is it's pay-as-you-go. So when you're not using it, it's not costing you any money. You can customize it to what you want. In addition to the survey setup, like what you saw with the 2-meter pole, you also have the option to turn your survey instrument, if I can put it like that, into a handheld option with the introduction of the DA2 handle, which actually fits your power bank right into the handle. It's got your Catalyst right on top, and then with a magnetic strip, you can mount your tablet, smartphone, or rugged tablet, whatever you want to put on there to use. This, again, is just an easy, lightweight version, easier to carry in the field. Again, it depends completely on the end user. The typical industries we've seen this equipment moving into, we've had really good successes in the GIS mapping and data collection. That's been the biggest area where we've succeeded with this. GNSS land surveying. So there's a lot of land surveying guys that actually already have the higher end GPS equipment, the base rovers, the total stations. But when they have an overflow of work and they perhaps have the need for, it might be seasonal work. They might have a season where they're extremely busy and they can't just cope with the system that they have, but they might have 2-3 months where they have really busy, where they could utilize a system like this. Again, it's a very low cost of entry, and when you're not using it, it's not costing you any money. You can activate it as you please. Land cadastral management is something else we're working on quite a lot with various countries. We're seeing actually a lot of requests coming for land parcel data capturing, countries like Botswana, Mozambique, utilities and mapping, and then as well there's quite a big uptake in the drone market in the survey world, and a lot of guys use this Catalyst DA2 to put down their ground control to actually georeference their aerial surveys. But I think this is also just demonstrating that flexibility again of the DA2. You're not limited to just those industries that we're talking about. We're seeing a wide variety of industries popping up. I've got a few examples here of here in the Western Cape. We've actually got a company that's invested in the Catalyst. They're working at a decimeter, a 10 centimeter accuracy. And they travel all over the province, capturing beehive data, monitoring the activity of the bees, where the queens are, and capturing this data and using it to track their beehive activity. Another one where we're seeing, actually, we've got 2 very good use cases of it, is guys using it for golf course management. So there's a guy that manufactures booklets for golf courses, and he captures all kinds of data. He uses centimeter accuracy, but they use that data to put on the booklets, their course slopes, the distance controls, and just really utilizing it very effectively. Also, still remaining on the golf course side, we've got another gentleman that actually has a 3-dimensional scanner, where he uses the catalyst to georeference those scans on golf courses. He then uses that golf course scan data to generate virtual driving ranges, virtual golf courses. It's actually very cool. Again, and then we've seen guys using it in road inspection and maintenance. So they will go and log data such as like potholes or areas of concern, marking out areas where there might be some problems on roads and surveying in accurate data at centimeter level. So this is really GNSS data for everyone. I mean, I think it's limitless. We're seeing so many cases where people just, it's opening a whole lot of doors for people to get into data capturing. Along with that data capturing, we've seen as well that a lot of the data being collected these days, and this is vast amounts of data, is with drone technology. Now, I like to focus on the compactness of something like this, where you can actually put it in the cubby hole of your car. And something like a Mavic 3 drone, we're seeing the guys pair these two as a good way of capturing ground data with your GPS, with the catalyst, and then also using something small, like we're seeing how powerful the drones are becoming with the Mavic 3s that have very long flight times. They're very small, very compact, can fit into the same cubby hole of your car. And this is just a good complementary system to actually capture a lot of field data and accurate field data. I think just again covering some of the frequently asked questions we get on the DA2 is how it gets its accuracy. And I just want to emphasize that point. It gets it directly from the satellite, from Trimble RTX. And that's a direct satellite connection. So one of the best things is you're in the field and you don't need a cell phone connection. You can work completely offline with this. You don't need a cell phone connection to get your accuracy. It comes directly from satellite. And will this replace general survey equipment like the base and rover and the total stations we saw earlier? And the answer is definitely no. I mean, there's definitely different cases where you need that kind of equipment. Surveyors need that equipment and rely heavily on that. This is for me, something to be flexible, to be used on project basis, to be used on guys that do seasonal work, things like that. So yeah, and again, who purchases these? We're starting to see this all over the show. It's different cases. It's just about anybody that has a need to capture spatial data can do with something like this in their car. Time's up, but thank you guys, and please follow us on social media. And if you have any questions, Bill, I don't know if we've got a bit of time or.
Do you have any questions?
Anybody?
Yes.
Sure. Sure thing. Sorry? Yes? MLID, yeah, correct. So it's a different brand. The MLID functions differently. This is pretty much one of a kind at the moment. I don't think MLID has something competing directly with us, but MLID do manufacture GPS technology, but they're usually in the range of what we see with a base station and a rover. It's usually a full combination system we see, yeah. But we utilize the same sort of technology, yeah, satellite data.
Good, thank you, Leon.
Great, thanks guys.